All right, so I'd like to explain the two problems that we had on our formative. One of them is given an equation, draw its graph, and then the second one, given a graph, create an equation that could represent that. So the first problem, given f of x equals cosine of 2x, sketch two periods and make sure you do indicate what scale you're using on the x and the y axes. Okay. So I kind of look at this cosine function and I know what the general shape of cosine is, and I'm noticing that I'm going to transform this with this 2 as a coefficient in front of the x. Well, that 2 serves as the frequency. This cosine wave will be moving twice as fast as a normal cosine function. And that fact that it's moving twice as fast means the wavelength of the period will be cut in half. And you know, some of your teachers may have talked about this idea of 2 pi over b, where this coefficient of 2 is your b value. So that's going to help me figure out what is the new period, or what is the new wavelength of this particular function. In this particular function, this wavelength is going to be pi. That's the only transformation of this function. The amplitude is not changed. We're not shifting up, down, left, or right. Just a fundamental change of our period based on this frequency of 2. So I think what I might do for my scale factor, I might even just go up here and call this 1, and then call this -1, just because I have a lot of squares to work with. And then what I might do is maybe kind of indicate, okay, cosine starts up here. That's really not the greatest color. Cosine starts up here because the cosine of 0 is 1. And then I might use this as my next tick mark. This is my next tick mark. This is my next tick mark. And then this is that tick mark. And just again indicate my scale, since my period is pi, so then I know that this right here will end at pi. Half of that would be pi over 2. Half of that would be pi over 4. So my quadrant, or my incremental value, is a pi over 4. There's 1 pi over 4, 2 pi over 4, which I wrote as pi over 2, 3 pi over 4, and then 4 pi over 4, which is pi. I'm going to replicate that on the negative side. Cosine's an even function, so the behavior on the positive will match the negative, as long as we don't do a transformation, left or right, or a phase shift, which we're not. So there is our labeled values, and then I know cosine will go here, here. I'm just like kind of sketching out the shape in my head, because I know what the cosine image should look like, and then make it green. So then I'm just going to connect this particular function, this graph. Okay. Now, you know, you should really try to make the cosine wave as smooth and rounded as possible, because if you think about it, as you move around the unit circle of cosine, the values gradually increase and decrease very predictably, very smoothly, very continuously. And then go ahead and graph this side as well. The follow-up to this particular problem says, okay, you know, give me the intercepts. And maybe I'll just highlight this a little bit thicker, just so you can see, make sure it shows up on the video. And so if you've labeled your graph accurately and appropriately, it'll be really easy to pick off the 4x intercepts. The 4x intercepts that I have here would be pi over 4, 3 pi over 4, and then negative pi over 4, and negative 3 pi over 4. But I mean, the function is continuous, right? It's periodic. It goes forever, and you could have picked any increment of odd power or odd multiple of pi over 4, and that would work for x intercepts. And whether you listed them out as points, or if you listed them out just as their x values, we accepted both. So if I go and say, okay, my x intercepts were negative 3 pi over 4, negative pi over 4, positive pi over 4, and positive 3 pi over 4 would be the 3x intercepts. Okay. For the second problem, where you were given a sinusoidal function, it says find an equation that could represent this graph. Now I use the word sinusoidal because it's the same image whether you pick sine or cosine. You could transform one into the other, like a sine into a cosine, cosine into a sine. But a lot of times what I like to look at is does it look more familiar or more characteristic to one of the other functions? So to me this looks more like a sine function that has not been transformed, because a sine function, if I start at the origin or start the line of equilibrium, then begins to increase. And I noticed that the peak of this is 5 and the base is -1. So clearly I'm not centered here on the x-axis. So I need to make sure I can figure out, well, where is that center line? Where is that line of equilibrium? And so I even like to even draw that in, saying, okay, here's that line of equilibrium. Right here is what balances above and below in terms of my peaks and my troughs. So that tells me two things. It tells me that the entire function has been shifted up 2, so I have a vertical translation, but then it also helps me figure out what my amplitude is. So from that line of center, from that equilibrium line, I know that I could deviate the same amount in both directions. That's what amplitude is. And so I'm deviating 3 from that line of equilibrium. So that amplitude change of 3 is going to affect my equation as well. So right now I've got a transformation that's a shift up 2. I have an amplitude change of 3. Notice the fundamental wavelength of the period is still going to be 2 pi. So I don't have a frequency change, so there's not going to be a coefficient in front of the x like there was in the first example, right? This coefficient in front of the x, this coefficient in front of 2, meant that it was going twice as fast. I only need to go out to pi. If I'm going out to 2 pi, then I don't need a change in terms of the graph. Okay, so I know it's a sine function because I'm starting on the y-axis at 0, shifted up 2 with a coefficient or amplitude of 3. So I'm going to go ahead and write that together, making sure it's y equals or f of x equals 3 sine. Again, that 3 is my amplitude of just x. You can put parentheses around the x if you want, that's fine. No frequency change, and then up 2. And that's the equation of this graph as a sine function.